Okay, good day, grade 11. So this is our new platform of teaching and learning today. So moving on, our topic for today is about the quantum mechanical numbers. So in here, what is it? Each color of light has a specific wavelength. Among the visible light, red has the longest wavelength. Take note of that. Yung red light has the longest wavelength, but it has the lowest energy. And of course, yung violet light naman has the shortest. It has the shortest wavelength and has the highest energy. Remember po yung Roger-Vieve po natin. So take note of that. Red light has the longest wavelength and has lowest energy, and violet light has the shortest wavelength and has the highest energy, as you can see in the atomic emission spectra. So in here also, when compounds of different elements are heated over a flame, so when we combine any kind of compounds of different elements, they react to each other, and it comes to a point where the hot gaseous atoms begins to emit light of a definite color. So, doon na yun papasok yung mga reaction. If we combine two different elements and we heat them over a flame. And analysis of light given off by the vapors of elements can be done more precisely with an instrument called spectroscope. And with the use of this spectroscope, one can detect a series of narrow lines. So makikita natin yung specific lines or arrow or narrow lines or the line of spectrum on the light given off by an element. Yung binibigay, yung sinushow na kulay ng isang element. And the spectral lines suggest different energy levels in atom. So dito, sabi ni Neil Bohr, how did Neil Bohr explain the spectral lines of an element shown in the spectroscope? Paano ba niya na-explain? So dito, each line in the atomic spectra of elements suggests definite energy transformations within the atom. So he also stated that electrons are moving around the nucleus in a circular path, just like sa planet po natin, yung circulation of our planets, the revolution. So parang ganun yung pag-ikot ng elements natin sa nucleus. So sabi dito kasi dito, this is similar to the planets revolving around the sun. So electrons in each orbit have the definite energy, and this energy increases as the distance of the orbit from the nucleus increases. So it means these orbits ay tinatawag na shells or even energy levels and are assigned each a number. So meron po silang naka-assign na different numbers, or the shells has its corresponding number of the energy levels. So first is N1, N2, N3, N4, and so on and so forth. And take note of that also that N1, it can be associated to K, and N2 to L, N3 to M, N4 to N, N5 to O, and so on and so forth. So yun po yung corresponding po nila. Tandaan nyo po yan. As long as the electron stays in its given orbit, there is no absorption or emission of energy. So wala pong nagaganap na absorption or emission sa isang energy. And if the electron kapag nakapag-receive sa niyang extra energy, pwede siyang mag-jump sa another higher energy level. So tawag doon is excited state. Excited states, meaning to say, meron siyang na-receive na extra energy para mag-jump siya sa another or higher energy level. Next is the electron in the excited state can return. Pwede siyang bumalik to its original lower energy kapag the ground state by releasing discrete amount of energy in the form of light. Kapag nag-decrease naman siya or nagtanggal siya ng isang energy level. So pwede siyang bumaba yung energy level natin. So from excited state, pwede siyang maging ground state. So, yun po sa energy levels. So, dito, as you can see in this diagram, as I have said, meron pong mga association, bawat orbits dito, mga circle. That is, itong una, N1, N2, N3, pag meron pa N4, N5, N6. As I have said, N1 can be associated to K, N2 to L, N3 to M, N4 to N, and so on and so forth. So, dito sabi ni Bohr's atomic model can only describe atomic spectrum of an atom having only one electron like that of hydrogen. So, an Austrian physicist, C. Erwin Schrödinger, together with Werner Heisenberg and C. Louis de Broglie, made a refinement. So, they modified the station or the knowledge of Bohr's atomic model. So, Schrödinger used ginamit nila yung mathematical equations to describe the possibility of finding an electron in a certain location. So, dito, they use the mathematical equation para to know the exact location to find the electron in the nucleus. So, this model is known as the quantum mechanical model of the atom. So, based on this model, it would be possible. So, dito, in this model, it would be possible to plot a definite path or orbit for the moving electrons. So, pwede nating ma-locate, makita yung mga gumagalaw na electrons in the nucleus. At least, we can only guess the most probable location of the electron in a given instant to be within a certain volume or region of space surrounding the nucleus. So, ano ba yung atomic orbital na sinasabi natin dito? So, an atomic orbital po is the region around the nucleus where the electron is most likely to be found. So, nakikita natin yung mga electrons sa atomic orbital po natin. So, the atomic orbital served as the house. Tandaan nyo po yan. Atomic orbital serves as the house of the electron. And it can accommodate a maximum of 2 electrons. So, sa una po dito, sa unang electrons or orbital, dalawang electrons yung kaya niyang i-hold. Dalawa. Take note of that. Then, sa susunod, yung pangalawa na orbital, yung kaya niyang i-hold is 6. At yung pangatlo, kaya niyang i-hold is 10. Next is 13. Next is 18. Next is 32. Yan po yung energy level na kaya nilang i-accommodate. So, aside from the main energy levels and atomic orbitals, there are also energy sublevels, are shown by the finer lines in the atomic emission spectra of the elements. So, dito, meron po tayong activity which explain ko kung how you will do it. Kung paano ba nakuha itong main energy level, number and kind of sublevels, number of atomic orbital, kind of atomic orbitals, maximum number of electrons. So, dito po, as you can see, yung main energy levels po natin, meron po tayong 7 or 8. So, N1, N2, N3, N4, N5, N6, N7. So, main energy level can be associated to K, L, M, N, O, and so on and so forth. Then, number of atomic orbital, paano po nakuha yung number of atomic orbital is that 1 times 1 is equal to 1. 2 times 2 is equal to 4. Let me draw. This one. 3 times 3 equals 9. 4 times 4 is equal to 16. So, 5 times 5 is equal to 25. So, dito naman, paano naman nakuha yung kind of atomic orbitals po natin? Instead that, sabi po natin kanina, sa SPDF, hindi ko pa po nabanggit yung SPDF na yan. So, meron po tayong sublevels na SPDFGHI. So, yan po, tandaan po natin yan. Sa sublevels, meron po tayong S, P, D, F, J, saan yung erase? J, H, then I. Tandaan po natin yan yung another kind of sub-levels. S, P, D, F, G, H, I. So, sa S po, ang pwede lang pong ilagay doon na number is dalawa. Dalawa lang yung kaya niyang i-hold sa S. Dalawa. Dalawa sa S. Sa P is 6. Sa D, meron pa tayong 10. Sa F is 14. And so on and so forth. So 14, 18, then 32. Tandaan po natin yan. S2, P6, D10, F14, G18, H32, and so on and so forth. So yung I is 50. 50 po yung I. So that's it. Yan po yung another kind of sublevels. So dito, paano nakuha yung kind of atomic orbitals? So as you can see, 1s. So isa lang yung sublevel dito, isa lang, 1. So ito yung 1s doon. 1s. So dito naman sa 2, dalawa na sublevels. So meron po tayong S and P. Pwede nyo pong ilagay yung 1s at 3p, pero pwede po yung 2s or 2p. Pwede po yan. Sa 3 naman, tatlo daw na sublevels. So meron po tayong SPDF. So SPDF. Or sa 3 is PD. SPD is pwedeng 3s, 3p, 3d. Or pwede rin pong 1s, 3p, 5d. Sa pang-apat na main energy levels is 4 daw na sublevels. So SPDF. Pwede pong gamitin yung 4s, 4p, 4d, or 4s. But pwede rin po yung 1s, 3p, 5d, at 7f. And then so on and so forth. Dito naman, paano nakuha yung maximum number of electrons is that, ganito po yan. Maximum electrons, kung ilan yung kayang i-hold ng isang sublevel. So, dito, sa N1 or sa S, mayroong dalawa. Sa P, 8. D, 18. F is 32. G is 50. H is 72. I is 98. Q is 128. So, paano na-derive? How maximum electrons derive? Ganito po lang siya. So, base po tayo dito sa 2. 2 times 2 is 4 times 8. Or, I repeat, 2 times 2 is 4. 2 times 2 is 4 times 2 is 8. So on so forth, magiging sa last is 128. So yan po, ganyan po nakuha yung maximum electrons that can be held in one sub-level. So I'll repeat lang itong diagram kung paano nakuha. So dito, meron po tayong main energy level na kung saan meron po tayong N1 hanggang N8. And also in this main energy level, it can be associated to S, P, D, F, J, H, I, Q. Wherein yung S means to say sharp, P, principal, D, diffuse, F, fundamental, and so on so forth. So hanggang lang po tayo sa SPDF. Sa J, H, I, and Q, advanced na po itong knowledge about the quantum numbers or quantum mechanical numbers. So, tandaan nyo rin po dito sa S, meron lang siyang kayang i-hold na isang orbital. Sa first orbital, P3, D5, F7, G9, H11, I13, Q15. And also, kung paano naman nakuha itong number of electron na gagamitin ninyo after nitong quantum numbers. Ito kasi yung 2, 16, or 2, 6, 10, 14, 18, 22, 26, 30, gagamitin nyo po yan sa electron configuration. So, paano nakuha ito is that 1 times 2 equals 2, 3 times 2 is 6, 5 times 2 is 10, 7 times 2 is 14, and so on and so forth. Yan po. And then, yung maximum electrons can be held, kung paano nakuha to, o paano na-derived, meron na po ditong formula kung paano to just analyze this, how maximum electrons derived. So, I hope that you understood. Next is, we have yung ito. So, how will you illustrate the atomic model of a given elements? Kapag nagbigay po tayo ng elements. So, dito, as we discussed, yung first orbit po, yung kaya niyang i-hold is 2. Next is 6, and so on and so forth. So, magbe-base po kayo dito. 2, 6, 10, 14, 18, 22, 26, 30. Diyan po kayo mag-base or sa maximum. Dito na lang kayo mag-base. Sa maximum. I'll repeat. Saan kayo magbe-base dito? On how will you illustrate the atomic model of the given elements is that sa maximum. Sa maximum, dito po kayo. Maximum electrons na kayang i-hold ng isang orbital. So, 2, 8, 18, 32, 50, 72, 98, 28. Hindi po yung sa electron configuration. I'll repeat, sa maximum electrons po kayo mag-base. So, going back, since yung example po natin dito is carbon C. Meron po siyang 6 na electrons. So, dapat 6 po yung makikita nating electrons po dito. 1, 2, 3, 4, 5, 6. Pero tandaan po natin na meron pong pattern on how you distribute the electrons. So, example. Since the carbon has 6 electrons, so, sa first orbit po tayo, sabi ko po kanina, 2 lang yung kaya niyang i-hold. So, 1, 2. So, okay na tayo dyan. Wala na tayong ilalagay dito sa first orbital. So, 2 na. So, kailangan pa natin ng 4 to make it 6 electrons. So, sa second orbit, ilan yung kayang i-hold ng second orbit is 8. 8 yung kaya niyang i-hold. Pero, yung kailangan lang natin is 4 kasi 6 lang yung electrons ng carbon. So, ganito po yung paglalagay. Dito sa taas, 1. Din sa baba, 2, 3, 4. So, to make it total, 6 electrons of carbon. So, ganyan po yung paglalagay on how will you illustrate the atomic model of the given elements. So, kapag yung element po natin, another example is oxygen. Try natin oxygen. Series natin. Oxygen po tayo. So, this element will be oxygen, which is yung oxygen po natin, meron po siyang 8 electrons. 8 electrons po yung oxygen. Wherein, nasabi po natin kanina, dito sa first orbital, is 2 lang yung kaya niyang i-hold. So, 1, erase natin. Repeat. 1, 2. Yan, 2 na. So, the second orbital naman, yung kaya niyang i-hold is 8. But, yung kailangan natin dito is, ilan na lang yung kailangan natin? 6. So, 1, 2, 3, 4, 5, 6. So, to make it total, 8 electrons of oxygen. So, ganyan po yung magiging illustration ng atomic model of element oxygen. So, ano pa ba? So, as you can see, meron po kayong assessment pretest in our new platform of teaching and learning. And of course, I have provided here a discussion, then answered these additional activities given in our platform. So cite your insights or learnings regarding in our topic. And of course, what is your realization or additional information about in our topic. Okay, that's it for today, and I hope you will understand our new kind of teaching and learning process. So once again, our topic is about quantum mechanical numbers. Okay, goodbye.